Why is that pink?
Because you made it pink.
Then people
probably.
say stuff about my aesthetic choices, and it's think that this changes the color.
Yeah, right. It's FOSDEM color. Quite right.
Ah, okay.
Yeah. Okay. Yeah. So Jose made an interesting decision in life, or several, I guess. This is a major one that GCC needs an Algol 68 front end, and that this language needs to have a vibrant community just a few decades later. So he's also setting up, not just he, but there's a team by now, setting up a Algol 68 web page and reviving the programming languages committee and inventing or coming up with stuff that you need nowadays that people didn't think about in the 60s, like I/O interfaces and all such funny things. Yeah, and the GCC now has an Algol 68 front, and you can use it to compile actual code, as we have seen before. And I'm sure you will have some more examples of that.
Yeah, thank you. Is this working? Yeah. All right, so first of all, I would like to say two things about this talk. First, I'm sure that at least some of you are here for some cool Mega, Sega, Dreamcast console gaming things. Instead, you are here for 25 minutes of two levels grammars, notions, proto-notions, meta-notions, and so on. No, I'm kidding. But there has been a change in the schedule, so Falco, I am sure that he's watching from home. All right, so this was, we don't have a lot of time. This is the reduced edition of an updated talk that I did in Cauldron, so we are going to do the following. For 10 minutes, I'm going to do an introduction of the project, about the language, blah, 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 blah. But I promise that as soon as I get the sign of it's only 15 minutes left, I'm going to shut up and I'm going to show you something cool, because I don't want all the blah blah to actually avoid the cool demos. All right, so let's get with it. Right, the elephant in the room. Why Algol 68? You are an idiot, because Algol 60 is, like it was completely superseded. Yes, it was very important in the past, but who cares about it anymore? Okay, first thing first. Algol 60 was Algol 60, right? And indeed, almost every aspect of that language has been superseded and has been developed by later languages. Yes?
Well, not according to 4.
I don't care. Algol 60 is basically, well, it has some historical interest, if you want to say that. Remains historical curiosity. It's actually a nice thing. Algol 68 is a completely different language. It has the same name. It was produced as the result of trying to evolve Algol 60 into something different, but it is totally and completely a language in its own that has absolutely nothing to do with Algol 60 in most aspects. All right? And this is a problem that they already had back in the past. There is a Algol bulletin from beginning of the 70s where someone was already complaining. We are calling ourselves Algol, so people throw things at us at conferences, and anyway. So it turns out that Algol 68 is modern. It's more modern than any other programming language, in fact, that is widely used today. It is powerful. It is more powerful as a matter of fact than any other widely used programming language around today. And it is safe. And when we finish implementing all the runtime checks, as a matter of fact, it's going to be safer than any other programming language actually widely used around today. Okay? And also writing Algol 68 code is a very, very special and nice experience, because the language is designed in a way that actually some of the stuff that you can do with it feels like magic. It's not magic, right? We don't believe in magic here. We don't do LLMs here. But we know that it's not magic, but it just feels like. So Okay, I have this timeline of Algol 68. I don't want to get very deep in here, but basically there was Algol 60, then they said, okay, let's do something else after that. Then it was Algol X. Then Wirth, Exmula, and Vingarden, they put together a proposal. Then they were commanded or commissioned to actually talk among themselves and come with some agreement proposal. They did not, of course. I mean, they competed among them, and then it was Vingarden who actually won, and that led to Algol 68. There was a lot of discussions. Then there was a small part of that committee that included Distra and also Wirth, that they were very bad losers, so they wrote a minority report, all nasty stuff. It doesn't matter. Well, then there was a revision, very important, the active support that lasted until around 80. And then in 1980, the Dark Ages started, which basically means that everyone started pushing for simplistic, extremely simplistic programming languages, like C, which are like macro assemblers, as Mohammed was saying before. What happened recently? There is another programming language, which is not Algol 68, that even though it's pretty nasty as a programming language, it has made something important. This is Rust. What has Rust done? Rust, for some reason that they still don't understand, it has managed to get people to again think about the tools they use to do stuff. And people are once again, after 20 years, 30 years of obscurantism, people are once again willing to start thinking about those tools. And they are willing again to use complicated tools to do complicated things. Right? Okay. Problem, Rust is awful. So when Rust crashes, and it has to, then Algol 68 will be there. Modernized and up and running. So that's the point. So to do that, we confirmed a GNU Algol 68 working group, and you can read there all the main characteristics. And we want to bring Algol 68 to the first line of programming and dispel all the food surrounding it. 99% of the stuff you will hear about Algol 68 is bullshit. And 99% of anyone that told you about Algol 68 is a bullshitter, because very few people have actually taken time to get a clue about the language. I am the 1% that is not a bullshitter, trust me. Okay, and of course we want to provide modern implementations of the language and well integrated documentation, and also important to maintain and extend the language. Right, what do we do? Can you actually see that? I don't know, it got sunny now. Must be a sign from the skies. Well, basically, we do all sorts of things. We do documentation. As Thomas mentioned, we have a homepage for the language, because now that's something. Now you have to have a website for the programming languages. We have a jargon file. We will see later why we have that. And we are evolving the language. We have an Emacs mode with my amazing color codes there. By default, an Emacs mode for editing two-level grammars. Don't get scared about that. You don't have to do that. And then we have the toolchain at the GCC frontend, but also the support in the auto tools, in AutoMake, AutoConf. We had to do some Dorf stuff as well. GDB is work in progress. We are starting it right now. We have support in Compiler Explorer, thanks to Mark here. And we have a community. Okay, so we have the homepage for Algol 68. You can look it up. The sources are in that Git repository. There you have resources, links to videos and whatnot. Then we have the mailing list, because we are all farts in GNU, you know, so we use mailing lists, and we like it. So you can subscribe in one of those links there. And we have an IRC channel as well, where we just hang out. And, okay, so this was like the working group, very fast. The front end. So this is a GCC front end. And you can see there, it's now in trunk. And what we do is that we implement the full programming language plus a lot of GNU extensions to the language. But as we shall see now, we don't just throw extensions to the language like the C++ or other people do, because we have some respect. And so we do it very carefully, very carefully. We have the front end has a user manual, an internals manual, and this is not up to date. And also we have a style guide for Algol 68. Since we are not that many writing Algol 68 now, we have the luxury of deciding how everyone else is going to write the language. So we keep a formal description of the language that the compiler compiles, in form, of course, of a two levels grammar. Yeah. And well, then we are adopting Unicode, and it's already available in some distros. Now, the architecture of the front end apparently is nothing out of the ordinary. You have a compiler, a driver ga68, a compiler proper a68.1, and a runtime library. I want to continue talking. Okay, well. Only one thing. You will see there that the parser looks strange because it does all sorts of things. And why is this? This is because of the main characteristic of this programming language. So very quickly, normally, if you read the definition of a programming language, you will always find syntax and semantics. And since Algol 60, precisely, since Bacchus and these people, the syntax usually are expressed in a context-free grammar, and then the semantics are expressed like in prosa, right? Like in normal English or whatever. Algol 68 is different in that regard, because it is simply not right to think that syntax is what you can normalize and semantics is what you cannot normalize. No, sorry, it's the other way around. It is not right to think that you can only normalize syntax and you cannot formalize semantics. It's the other way around. So in language specifications, what they call syntax is what they can actually formalize in a way that it is readable and you can operate with it. And the rest is semantics. But it turns out that of the programming language semantics, you can do a further division, which is you have the dynamic semantics and the static semantics. The dynamic semantics is any characteristic, any semantic that relies to evaluate, to calculate some value, right? But there is a huge expander which is like the static semantics for aspects like you cannot use an identifier if it's not been declared before, or the widening coercion, which is you can transform from integer to real only here, or many other things. And in which order those conversions happen. Do you convert first to reals and then you convert it to this, or the other way around? Well, it turns out that a lot of that can be actually formalized, but not with a context-free grammar. Now, you can formalize this with a context-sensitive grammar, but it is unreadable. It's almost unwritable, and for sure, certainly unreadable. It's not practical. And that was the genius of Bin Garden with the two levels grammars. The two levels grammars, what you achieve with that is that you can express, you can formalize in a two levels grammar a lot of restrictions, especially applied to programming languages, that you could not express in a context-free grammar in a way that it is readable. Okay? And that's what they achieved. And that was the big wow. And as a result of that, Algol 68 is a programming language in which almost everything is defined by the syntax. But the syntax, when we talk about syntax, is the traditional syntax, context-free syntax, plus all those extra aspects. That's what makes the language perfect and eternal in an orthogonal frame. Okay? Okay. Well, very quickly, what's up with development? We sent the first patch series to GCC in January 25. We were off 3 for a while, but then we integrated in Trunk in November of last year. We implemented the module systems, the FFI and whatnot. So this means that when GCC 16 gets released by spring, more or less, it will include the Algol-assisted front end. Okay, the home page, the test suite. This is the two levels grammar, so on. Okay, I will go through the. I'm sorry. I did not expect that we will be able to show you all this, but okay. So now I want to invest the last 10 minutes like showing you some Algol-68 code, because one thing is to talk about it, and something else is to actually take a look at it. We are going to take a look to two different applications. One is a program. It's called ga68, and it's a command line interface to Compiler Explorer. So you can do something like this, like list compilers, and let's use the, I don't know, or ga68 format foo.c, whatever. So this is a command line interface to Compiler Explorer. Compiler Explorer is a web thing, which means that you have to use web things. And that includes JSON, HTTP, and all sorts of other nastiness. And this program is written in Algol-68. And as you can see here, well, this is like the build system. Okay, this is a patch. Forget about that. And so you have a configure.ac, a makefile.am. So let's take a look. You have an ACProc 868 in autoconf already upstream. So it's basically the same that you will do in C. And then once you call this macro, then in automake, okay, this is just the subtiers. And those are like the source files, and you just have a primary normal automake primary with the normal sources, and if the extension is A68, automake knows what rules to generate and everything. How the source code looks like? Well, this is the main program. Yeah, okay. So, I mean, so this is begin end, because this is a particular program. Then it accesses some modules. You specify it accesses globals, JSON, and RP. JSON contains the JSON specification. The RP is the other. It has a string with the version. Then you have some procedures here. You see that in Algol-68 you do procedures like very casually, because they are like any other value around. You pass them as arguments and as callbacks and all sorts of stuff. But let me show you something like juicy. JSON. So this is an Algol-68 complete JSON parser and writer in 322 lines of code. So basically this is a module called JSON. So what is a JSON value? Mode in Algol-68 modes are types. So a JSON value is either a union is either nothing, or a Boolean, or an integer, or a string, or a JSON array, or a JSON object. A JSON array is a set of elements. A JSON object, it has fields. A JSON element, it has values and next, and so on, you see? Now you have some nihils here that we call them, which are like null values for those references. So if you call JSON new object, it returns a JSON value that you allocate on the heap. And you write it as simple as this. This is a variable JSON error, which in fact can refer to a procedure that gets a string and returns no value. And the default value for that is this routine that gets a message, a string, and does nothing and calls assert fall. This is what you will call a lambda in uncivilized languages, but we call it routine text. And the pub here is that this particular entry or this particular declaration, they are public of the module. If you use the module, you get those. This is an operator. You can define operators and you can overload them. And yeah, look, this is a nice operator. This is an operator, arrow, whatever, and that gets a JSON value and a string, and then you can create some sort of syntax with this. Like you create a new value, then you say object name equals this, and this operator is basically internally creating an entry into this composite JSON value, right? It's handy. Then this is the code to get a JSON value and print a string. You will see it's very declarative. Is you get a JSON value, then if the value is a void, you print null. If the value is a Boolean b, then according to the value, you print true or false. If it's an integer I, then you convert to a string. If it's a string, you just quote it. If it's an array, then you iterate among the elements and blah, blah, blah. It's very declarative. I think it's very readable. And this is the parser. This is a parser, and this is not a Mickey Mouse parser. This is a real one. Like, it gets a file descriptor and tries to not allocate everything in memory. I mean, it's serious stuff. And yeah, well, you see, you know, you have all those auxiliary procedures. You pass a value, and this is the parser. The parser is like 25 lines of code. And like creating procedures, passing them as callbacks, creating stuff on the heap. And JSON for each element and so on. 320 lines of code. Okay, let's see the HTTP, because to talk with compilers per, you have to do HTTP, unfortunately. Okay, so this is the implementation of HTTP post in Algol 68. You get a socket, you get a URL, then you get headers in the form of a multiple, which is an array of structs, each entry two strings, name and value for the header. Then the contents, you can provide them either as a string, so that it sends as is for short stuff, or as a procedure that gets a reference to a boolean and gives you a string if you want to send big contents in chunks. Then the response, you get it using another callback, and then you specify if you want it fragmented or not. And this is basically how it looks like. I think this is, again, very readable, and yeah, and it's short. Then you have HTTP GET and POST, complete implementation in 221 lines of code. Okay, but there is more. Let's change program. libterm68. libterm68 is a library, because I wanted to do like a shared library to distribute, to test our module system and everything, that basically it gives you like it's like a mixture of end courses and something else. I don't know. It's like ANSI terminals that you can have little windows, you can print colors and all that stuff. And okay, so basically you have like a tree structure. Okay, so how this looks like? Well, in the build system is very similar. You see, you create in Automake like a libtool library. Libtool supports this, and then you have Algol 68. But note there is one which is C here. Now you will see what it's for. Okay, so libterm68. What is the top level of the shared object? It's a module called term68 which accesses these others and just adds a version string. Okay, what is the stuff? Well, for example, here. So this is the module, the terminal. This is the terminal. The terminal itself is an input file descriptor and an output file descriptor, a standard input, a standard output if you want. Then when you call term open, it gives you a terminal and a default viewport, which is a region in the terminal that covers the full terminal. And you see how a ref argument is used here to get the passed by reference parameter, right? And then you have different services here, like safe state, blah, blah. 391 lines of code. Okay. Then the ANSI interface is another little module. The positions, right, which is like the positions of column rows. You have some handy operators here. So you have the mode position, which is columns and row, and then you define operators, operator plus, operator minus, operator bigger than, and so on, right? 70 lines of code with comments and headers, and so on. And now the C part, which Mohammed already showed something before, but for example, this is a C interface to the tcset attribute and tcget attribute for terminals. And basically, well, I create those two functions, term_ios tcget attribute and term_ios tcset attributes, to simplify the interface, because instead of a term_ios struct, they get like 3 sets of flags in unsigned integers. You have to do this because the term_ios struct in POSIX is secret. you have 3 fields, which are those, or 4 that you know about them, but there can be anything there. So you need to do this. And so this is compiled along with the library. And then you have the Algol68 interface to that C code, which is we define the term iOS struct in Algol68 with the 3 flags. We define some flag numbers here. And we define here, this nest C is a C formal hole, right? That basically this is, okay, this procedure, CTC get address, which is this Algol68 procedure, corresponds to the C1. And you can use it as normally. You can, as Mohammed has shown before, you can do the same with variables and with other stuff. So there is a good interface with C. Because we want to be good citizens in the system. We don't want to be a ghetto language, like Go, like even Rust, everything is static. We have to rewrite the whole world, in our language because otherwise, everything is horrible. No. We like shared objects, we like linkers, we like the system, and we want to use it, and we want to integrate properly. That's the idea. And trust me, we are going through big pains to make that so, like in the implementations of the modules and everything else. I don't have time now to detail how the modules are implemented, but we did it in a way that it's not intrusive. You don't need cargos, you don't need special tools to build, you don't need like ADA special linkers. No, you use the normal linker and you use the normal make and everything works, okay? Okay, and yes, time is up. Okay, so I wrote a little demo, but I don't know where it is. It's here. So basically, you have a terminal, you open it. This is a little Algol68 program. You open it, this is for drawing a frame around, this is rainbow to change colors in text, and then it does all sort of, this is for testing the library basically. And so let's run it. Have it ready here. Where is it? Here. So I am in the same directory, so I'm not cheating. I have here a script which just calls the compiler with some -I options and -L options. So let's build it. And now I execute the demo, but I have to add the LD library path because this is not installed. So the real shared object is in .libs. But it's just one shared object, this library. It doesn't have header files. And see, it works. So now this is a Mickey Mouse demo. But I wanted to make a Tetris, but no. I'm sorry, but no.
Are you serious?
Yes.
That's very serious.
Yeah, I am serious.
What's your computer?
What? What computer?
What computer are you using?
This is a Panasonic TalkBook that you can find in internet for 250 euros used, refurbished. But 10 years ago, they were like 3,000 or 4,000 euros, and I could not afford them. Now I have like 5 or 6 of them. Yes?
Is the Algol68 report still can you still buy it? Or?
No, you can find in eBay. Oh, sorry. I'm sorry. The question was if you can buy the revised report. You can find copies, either original or facsimiles. Some people are doing facsimile. But we plan to do a revision. And we also plan to do a revision of the informal introduction to Algol68 from Charles Lindsay and many other stuff, yes.
Could I repeat my question from earlier? How does the stropping discipline work in your implementation?
I went through that, and I did not went through, how the stropping works in our implementation. Okay, very quickly. I did not want to go through that because, the Algol68 code that you can see in internet looks like this. For example, this is using quote stropping. It's very old stuff. Yeah. This comes back to the times where you only had one alphabet in your computer and was usually uppercase. And it happens that the Algol68 syntax it distinguishes between bold words and normal words, and bold letters and normal letters. But now, then there were different bold stropping. This is called stropping. Stropping is this technique to distinguish between what is a bold word and what is not. And this was quote stropping. This is dot stropping. You see that it's dot before. This is reserved words stropping that was not very successful because some of the words become keywords, but you cannot do it with the words that you defined yourself. And this is the classic upper stropping that is supported by GCC, in which the bold words you make in uppercase. We were happy with this upper stropping, but other people are not. So what we did was, as a GNU extension, we added support for bold taggles, for underscore, and then we created what we call supper stropping. We call it supper stropping because it's sort of a mixture between upper stropping and rest stropping. And basically, we managed to come with a stropping regime that is still a stopping regime, therefore way more powerful than coding conventions.
I can still have a variable called int.
Exactly. You can still have a variable called int on the spot. Thank you very much. And but it looks like nice for the kids, right? Like, yeah. So mission accomplished on that regard. Yeah?
So it's garbage collected, right?
It can be garbage collected.
And how does it interact with FFI? If you allocate some memory in C,
Yeah.
then how do you space?
At the moment, you are on your own.
So you have to free.
Well, actually, at the moment, we are using a conservative garbage collection, which is like not wearing anything. But yeah, I know. But we are going to change to a precise garbage collected ad hoc, and yeah. But for the moment, you are on your own. Good luck.
Is that part of the syntax or?
No, it's not. Yeah?
You could write a shorter JSON parser in Haskell.
What did he say?
True. You can write a shorter JSON parser in Haskell.
I don't know. I can't hear you from here. I'm sorry. Yeah, time is up. Oh, I'm sorry. Time is up. We should do it maybe later. Thank you.